Hello, everybody. My name is Luca Tamburrano. I am an SE lead in Talend, and today I will introduce my team, Lambda Corp, and the amazing project that we are going to present to this Hackathon 2022. Let's start from the presentation of the team that is composed by myself, by Javier Paya Aguirre, that is a part of the professional services team, and by Felice Bellanti and Ben Sanders, that are part of the SC team as I am. The agenda will be pretty simple because we are going to define the problem. We are going to define also what are the MVP features for addressing this problem. We'll spend just one slide to explain the benefits of having a dynamic replication mechanism within Talend. Then we'll introduce very briefly how the Kafka-based CDC systems work. There will be a short demo, and then the definition of next steps and conclusions. Now, when you talk with solutions engineers, actually all of them will say that Talend needs a real-time data replication solution to support real-time analytics and operational use cases. This is something that in many cases jeopardized our deals, and some deals have been lost because of this. So sometimes we were able to propose a stitch, and stitch actually works quite well for the incremental loading, but unfortunately doesn't support real-time use cases. This is why we acquired just less than 1 month ago a solution, a CDC solution called Gammasoft. And so another question that all the solutions engineers have is, okay, but how are we interacting with it using Talend? This is how we scoped the minimum requirements for addressing this problem. So, of course, the solution must be underpinned with the log-based CDC solution. It must provide real-time reads from RDBMS sources. And of course, it must replicate data and schema changes in real time, also respecting the order on how this change occurred in the sources. Another requirement that is fundamental is the integration with Kafka, because we noticed that many of these CDC platforms use or can use Kafka as main storage for their real-time transactions. And the Gammasoft is one of them. There is also Debezium, HVR, and many others. It has to be delivered, of course, as a Talend artifact, and must dynamically handle payloads for data schema changes and send to destination without manual intervention. Why this is involved? Because actually the dynamic replication is fundamental when we are talking about possible CDC solutions. Because first, it reduces time. So actually the users, they don't have to create different pipelines for each table that they want to replicate. It improves scalability because actually I want to be able to have something that automatically handles new sources being connected with no additional configuration. And also what we want to achieve is lowering the maintenance of such a system. So it means that once configured and operational, we don't want to have any other user intervention. Now, how do Kafka-based CDC work? This is quite simple because actually you have some agents that can be invasive or not invasive, like for Gammasoft, that basically are retrieving the transactional informations from the different sources, writing them into Kafka. So what we call the delta informations are written into Kafka. This is where our solution comes into the game, because actually what we implemented was a system that can dequeue these messages from Kafka and replicating them into a target schema that we decide. Now, since for the time being, as for today, we still don't have the availability of the Gammasoft platform, We used Debezium. Debezium is an open source CDC platform that works in a very similar way respect the Gammasoft, because actually also it provides a non-invasive agent that determines the delta information from the sources, writing them into Kafka. Let's jump to the demo and to the description of what we implemented so far. So here, basically, we implemented two routes. And we implemented two routes because Debezium basically writes the DDL messages. So it means the creation and the drop of the tables in one schema into one single Kafka queue. And then creates as many Kafka queues as many tables are present in the schema. So this is why now we implemented one route for reading the DDL messages and one route for reading the CRUD messages. Now, what is very important to know here is that these routes are invoking Talend jobs. So there is one Talend job for the create, one Talend job for the drop, and one Talend job for all the CRUD operations. What is very important to know here is that these jobs are exactly the same for any message that is hitting Kafka. That means that this map that we created can be used for any message that is hitting it, regardless of how many fields, how many types and different types that the message is managed. The second part that is very important is that we are generating the SQL queries that will be executed in our target. And actually, in order to generate these queries, we implemented a routine that is using the internal methods of Talend for generating the query. So for example, here we are using this dynamic utils class that is exactly the same class that the Talend code generator is using, making easy and quite easy the integration, the future integration of this code within the Talend base as well. And the biggest thing that we did here is that we are managing finally the keys in the dynamic schema. That is something that the actual implementation of Talend is not managing. So given this, now let's move directly to the demonstration. So we have one schema here called self-service, where I'm going to create one table called Debezium customers. Let me create this table. Now, going back to the route, we can see actually that a message was queued by the Kafka queue, and then a query has been created and executed. Actually, here we are defining very simply some context variables, where we are defining what are the we are defining a prefix that we want to put before any name of the tables that we are creating in the target schema, and the name of the target schema. Indeed, now, if I'm going back here, here is my target schema. Refreshing it, we see that a new table has been created. Now, let's invoke a Talend job for populating it. Let me run it. I'm going to create 100 rows. All right. So once I created these 100 rows, I can see here that in this the route actually performed the 100 rows inserts. Indeed, if I go back here, I count the number of records in the table, in the main table, the number of records in the replica table, and we can see that are 100. Now, let me go here, and let me show you how also the other CRUD operations work. So I'm going here, and I'm going here. We can see that the records are exactly the same. Now, let me remove one, let me change one record from the main table. So let me go here. I put Luca Burano. All right, let me save it. As soon as I save it, you can see that there is a new message that has been created here, and indeed an update has been generated. Indeed, if I go here and I refresh the content, you can see that I have Luca Tamburrano here. Same thing if I am deleting the record. So let me delete it, let me save it, and then going back here, it's been removed. So actually, we were able to manage all the DDL and CRUD operations in real time. Now, what's next? Let's say that the main parts, technically speaking, of the solution are the mapper, the mappings that have been created with the Talend DataMapper, and the dynamic schema management. So an improvement, of course, will be creating the TDM mappings to support Kafka schemas from Gammasoft. Why this is the only thing that is needed? Because actually, going back to the demo, here we implemented basically a model of structures that we need, that in case of CRUD messages, we need the names, the types, and the values of the records that we are going to replicate. And similarly, for the DDL, instead, we need different values. But actually, this is a model that can be that is populated by the result of the data mapper. So regardless of what message the data mapper is dequeuing, so coming from Debezium, coming from Gammasoft, coming from HVR, coming from any other system, actually this defines a model that can be reused in all those kind of situations. Of course, a second point, we want to test it with wider range of sources and targets. Since we are using Kafka, we can also implement a dynamic Spark streaming solution for destinations like Delta Lake, and that can have incredible potentials, commercially speaking. Of course, we want, once consolidated, we would like to create demo content and also videos for sales and solutions engineering teams, and also evaluating the creation of an implementation accelerator in Talend Academy. So what are the conclusions? Actually, using a solution like Gammasoft, Debezium with Talend offer flexibility and additional support for replication destination connectivity. The dynamic schema support in Talend Studio makes it simple to support any data source that is connected to the CDC solution. So what we wanted to highlight is that with just a small amount of work, we can leverage internally the dynamic schema in Talend for supporting the keys, and also for thinking about enhancing also the actual components that we have for support more and more the dynamic schema. And actually, the CDC with the Kafka as a broker increases also the connectivity with the wider Talend platform. Indeed, it can be used for real-time observability solutions in Talend inventory, or for example, we can decide to apply on the fly data quality rules right before these delta messages hit our replication schema. So we see a great potential in the acquisition of Gammasoft, and we strongly believe that Talend is the platform that can address all the issues related to CDC and real-time replication. Thank you, everybody. I hope that you enjoyed this video.